How you doing? This is Brian Devine. I'm the math guy at Hamilton Education, and today we're here to go over the key to the math section of the Hamilton Digital SAT 306. Now, do remember, you don't have to watch the whole video. You don't, I know it's scary, to have to go through corrections, but you can click on the bottom on the scroll bar and just go to the question that you want. So let's do that. We're going to start with question one and go from there. Question one, the function h is given as h of t equals t cubed plus 12. What is the value of h of negative 3? I'm just going to stick negative 3 in for t then. So h of negative 3 would be negative 3 in for t cubed plus 12. Negative 3 cubed is negative 27, and I'm still adding 12, and that sum becomes negative 15, which is the correct answer. Question two, the total for Juan's new e-bike was $899. He made an agreement with the bike shop to make an initial payment of 122 on that total of 899, with the balance paid in M monthly payments of $111 each. Which equation below best models this context? Well, if the amount 899 is equal to the initial value plus 111 every month, then the words translate into that particular equation. I don't see that, but I do see something here where if I take 111m away from both sides, I get one of the answers. And that's a valid move. Subtracting 111m from both sides will eliminate it on the right. It'll show up as negative 111m on the left, and D is your answer. Question number three. In question number three, we have two lines, A and B, that we're told have the same slope. They're parallel. And lines C and D have slopes of opposite magnitude. Now, what does that mean? It means that they're the same measure. In fact, if I were to look at this line that's going to split right between the two, where the intersection of lines A, B, C, and D, or pardon me, A, C, and D up above, and treat that like a coordinate system, then I have the basic idea that this angle here, one, right here, and this angle here have to be the same measure because of that idea of a reflection across that line that I wrote that I'll call E for now. Well, you can look at it like the y-axis and A is the x-axis, and both those lines C and D are going through the origin, and one has a slope of m and the other one has a slope of negative m, not negative 1 over m, but negative m. Okay, cool. Now that we've gotten that all taken care of, we can actually answer the question. So they tell me that angle 1 is 43 degrees. Well, that means that angle 4 is 43 degrees. And we already know from what we just talked about that this angle here has to be 43 degrees, which means that this angle here, because those are vertical, are 43 degrees. And if you just look on this one side of line A, then this angle in between here must be 180 minus 2 times 43, which would be 86. So 180 minus 86 means this must be 94 degrees. And that one's vertical to the angle that we're talking about. The one that's vertical to 3 right here would also be 94. That's not a 4. That's a 9. 94 degrees. And so angle vertical to 3, the answer to the question would be 94 degrees, which is D. Question 4. If y equals 6x minus 8, what's the value of x when y is 10? So 10 equals 6x minus 8. Add 8 to both sides. 18 would equal 6x. Divide both sides by 6, and x would have to be positive 3. So C is the correct answer. Question 5. The bar graph shows the frequencies of correct answers given in the Final Jeopardy category of the game show Jeopardy during 20 distinct primetime broadcasts, grouped by ages of the contestants answering. What is the mode of the data displayed? Now, remember what the word mode means. The mode is the one that shows up the most. So this would be the most frequent. And I go up above and I look at the ones that show up the most. And I see something right away that these two intervals show up both 4, and these two intervals show up both 1. And the idea of a mode is, well, I can have more than one mode. The mode means the ones that show up the most. And so I do have a mode at 4, meaning that there are more 4s than, or pardon me, more 4s than any other range of data, I should say. And there are the equal amount of 1s. And so this would be what is called bimodal. And so I have a mode of 4 and 1, which tells me when I state that I have more 4s and 1s than any other single set of data, and they show up at the same amount. And so A then would be your correct answer. And I do want to correct, I know that the value of 5 in that range 50 to 60 shows up more than 4, but the intervals is what we were asking about, the mode of the frequency data displayed. And so we look for the stacks that are the same height and report them. Question 6. At the local Jen and Barry's ice cream emporium, the manager took a survey of every customer that ordered ice cream last Thursday and asked what flavor of ice cream would you pick? And then he sorted their response by age group as shown in the table above. If a teen was chosen at random, what is the percent probability that they chose vanilla? Well, the question basically drives the answer here, is that if a teen was chosen at random, well, that would be out of all the teens. And if I look at that and add those up, 12 plus 16 plus 45 is going to be 73 teens. And of those, 16 preferred vanilla. And so by the wording of the question, how many? 16 out of what group? 73, the teens. And if I run that calculation, I get 0.2192, which implies 21.9%. And so I see that as an answer, and C is the correct answer. Question 7. Square S has two sides with a combined length of 20. So square S has two sides with a combined length of 20, then they must be 10 and 10. So this is square S. Square y has a perimeter that is 1/2 of square s. Well, that would mean all lengths are then 1/2. And so it would have a perimeter 1/2, then its side lengths must each be 1/2. So this must be 5 and 5 in square y. And I want to know, what is the length of the diagonal in square y? Well, this is a 45, 45, 90 right triangle when I draw that diagonal. So this diagonal must be 5 root 2 from the given reference and from prior knowledge. So A would be the correct answer. Question 8. In question 8, the graph depicts the relationship between the length of a spring with one end attached to the ceiling and various weights that are then hung from the other end. What is the best interpretation of the y-intercept? So the y-intercept then would be where it crosses the y-axis here, and they don't do the tricky trick of screwing with the graph here, so that looks like it's about 8-ish. So that would mean that, well, when there's no weight attached, when the weight is 0, that it must hang 8 inches long. The spring would be 8 inches long because that would be the length of the spring in inches. And the only one that says that would be D. It's the initial value before any weight is hung. Number 9. In number 9, we have, what is the equation of the line that passes through the x-axis at 5? So it must have an x-intercept at 5, 0, or 5 zeros on this line, and it's perpendicular to the graph of this line. And I note right away that this is in slope-intercept form. So the slope of the given line of reference is 5. So the slope of the line that we want must be -1/5, which means it's not going to be A or B. I can see that right now. And the line should be y equals -1/5 x minus 5 plus 0 when I stick the point and the slope into the point slope form. And so I get -1/5 x plus 1, which is C. Question 10. The exponential model A of t equals 580 times 1/2 to the t over 1158 for t greater than or equal to 0 models the mass of a sample of the radioactive element nobranium that is left after t years of decay. And how much time in years will there be 1/4 of the initial sample of mass? Well, what they wanted was, if I take 0.5, which is 1/2, and I square it, I will get 1/4. And so this thing here will equal 1/4 whenever the exponent equals 2. So I must have that t over 1158 equaled 2 in order for me to get 1/4 of the original sample. And if I take this and multiply both sides by 1158, I get t equals 2316. So in 2,316 years from when we start looking at that thing, 580 grams will then be 1/4 of 580 grams. And D is still your answer. Question 11. In the cubic function, f of x equals the product of 3 lines, 2x minus 3 times x plus 7 times x minus 2. If that is translated down 6 units to form some new function that we'll call g, we want to know, what's the y-intercept? Well, note that if I do multiply out the three linear factors of f of x, that the number on the end is going to be -3 times 7 times -2, which will give me 0, 42 will be the y-intercept of f. And then if I take that and translate it down by 6 units, well, 42 minus 6 should be the new y-intercept of g. And it is. Now, you could have graphed that thing in Desmos. Might have taken you longer to do than what I just did. But the answer still would have been 36. Question 12. A cone of ice was made from 22 ounces of liquid. It had a base radius of 3 inches and a height of 4. The cone started melting and it lost 2 ounces every 3 hours. When last checked, the amount of solid ice was 14 ounces. So it went from 22 down to 14, which means it lost 8 ounces. How many hours had the cone been melting when last checked? Well, we look at this rate of 2/3 of an ounce per hour. I mean, that's what it said, that it lost this much over the time that it melted. And it was going down by -2/3 of an ounce per hour, which is the same as -2 ounces every 3 hours. So if I look at that, then we must have had that, 8 ounces, and it's going down by 2/3 of an ounce per hour. The ounces are going to cancel, and I'll end up with 12 hours, 3/2 of 8. So it took 12 hours for the cone to go from 22 to 14 at that rate. Boom. Question 13. In 1834, chemist Benoit Perron is credited with stating the ideal gas law. For a given mass and constant volume of an ideal gas, the pressure exerted on the sides of its containers is directly proportional to its absolute temperature. Now, of course, Benoit said it in French. They may have translated it into Latin, but that's what he said when translated. What it means symbolically is the ideal gas law, PV equals nRT. So PV equals nRT. And then they tell you what P is, what V is, what T is, what N is, what R is. But the question says, hey, what is the value of the gas constant in terms of everything else? So solve for R. Well, I can divide both sides by NT. And they will factor on this side. So R should be PV over NT. And I look over to the left and I don't see that, but I do see this. And I know that I can write 1 over n as n to the -1. So I could have written this like this. It would have been more to write, which most people don't like to do, but it is the answer and it is valid. And C is the correct choice. Question 14. In question 14, I have triangle ABC and XYZ are similar. Angle B corresponds to angle Y. Angle A corresponds to angle X, and, pardon me, they're both right. So I should have something like this, that here's A, well, let me label it first. A is the right angle, then B, then C, and then this is similar, same shape So same acute angles correspondingly to X, then Y corresponds with B, then Z. And the sine of C is going to be 19 opposite over 81 hypotenuse, which would be the same as the sine of Z. And I want the value of the cosine of Y. Well, the cosine of Y would be the same as the cosine of B because these guys are the same measure due to the fact that the triangles are similar. So that would be 19 over 81, which you could write as what, 0.2345 or 0.2346. All of those were allowable. And remember the lesson that if I have a right triangle and I know the value of one of the angles and I know the we'll say this is opposite, this is adjacent, this is hypotenuse. Well, I know the other angle is going to be its complement, 90 minus x or pi over 2 minus x. And the sine of this angle is the cosine of that angle, and the cosine of that angle is the sine of that angle, and the tangent of that angle is the cotangent, and so forth. The whole function identity. But the answer is still 19 over 81 or 0.2345 or 0.2346 were all acceptable. Carry on. Question 15. The product of two positive integers is 192. And the first integer is 1/3 of the second. What is the sum of the two integers? So if I say let m and n be integers, and then I know that m times n is 192, and I'll say m is the smaller, is 1/3 of the bigger, which is n. Or better yet, 3m equals n. So now that I know that, I can take this product, and I'm going to end up with m times 3m, 3m squared equals 192. So m squared would be that divided by 3, which is 64. And that tells me that m equals 8. And n would be 3 times that, which is 24. So 8 plus 24 is 32. Number 16. Number 16, you could graph that thing right away. I mean, if I were to go into Desmos and graph that thing, I'm going to get something that looks kind of like this, and it'll do something like that. And I know that this will be 3, and this will be like negative 31/3 over here. So you can graph that. And you want the value of the least solution. So this is the absolute value graph, and this is the square root graph that you just graphed. If you did graph it, you want the one that's on the side. And you would find that it would be -2. Now, I could also do this. I could square both sides of the equation, and I'm going to get x minus 3 squared would equal 3x plus 31. So x squared minus 6x plus 9, foiling that out, would equal 3x plus 31, which would give me x squared minus 9x minus 22 would be 0. And that's pretty easily factored into x plus 2x minus 11. Actually, I think my picture was a little goofy. We should have had this like that. There, that's better. Equals 0. So x would be -2 or +11, and -2 is surely less than +11. So -2 is your choice if you want it correct. Question 17. I just can't read my notes here. Question 17. According to the wakanda.gov website, vibranium has a density of 397 kilograms per cubic meter. And remember that density is mass divided by volume. If a sample of vibranium in the shape of a hemisphere has a diameter with a length of 1 meter, so they just told us that the radius of that is 1/2. What is the mass of the sample to the nearest whole gram? And we note that 1 kilogram is going to be 1,000 grams. Well, first we need the volume. So the volume of this thing is going to be 2/3 pi times 1/2 cubed. Remember, the volume for a sphere would be 4/3 pi r cubed. This is half a hemisphere. And so it's 2/3 pi r cubed. And we then can use that idea that, well, the mass then should be the volume, which is 2/3 pi times 1/8 times the density, which is going to be 397 kilograms per cubic meter. And when we do that, we're going to get, well, we'll get the number 103.934, and it will be in kilograms. And so C is the correct answer. Question 18. In question 18, for all positive values of x, the function a is described as a of x equals 0.97x. Note that this is a linear form and that the slope would be 0.97. And 0.97 is a positive number. And so this would be an increasing linear form because slope is positive. So the answer is A. Question 19. In question 19, the rational function r of x is graphed on the xy coordinate plane as shown above. And there's some other function q of x, which is defined as some sort of transformation of r of x. In fact, what they said here was move r of x left by 4 and up by 1. Or pardon me, 4. So we're going to move r of x up 4 over 4. So in effect, I'm going to take the two asymptotes there and I'm going to move them up 1, 2, 3, 4, and over 1, 2, 3, 4. And so now the new asymptotes will be over here because we're just moving the whole darn thing. And that would be a valid geometric interpretation. And the asymptote moved from here to here, which means if I go backwards from the current x-intercept down 4 and over 4, I should get what will be the new x-intercept. And note that it's going to make the same transformation that the intersection of those two asymptotes did. It's actually going to go right over there. And so my new x-intercept will be at the same place that the old one was. Same place that the old one was. Number 20. In number 20, a gallon container of peanut butter pretzels costs $12.60 at Grazier Farms. And at Food for Far Less, the same product was discounted 40%. Now, remember, that would be then 60% of, if I take 40% off. And at No Costco, that same brand of pretzels comes in a 2-gallon container, each for 25% less than paid for 2 single gallons at Food for Far Less. How much money is saved by buying 1 2-gallon container of pretzels at No Costco versus buying 2 single-gallon containers at Grazier Farms? Well, there's a bunch of ways you could approach this, but we can take it right as it's written. They said that at Grazier Farms, you got 1 gallon for $12.60, which means that Food for Far Less, you'd have 1 gallon, 0.60 times $12.60, which equals $7.56. So at No Costco, for 1 gallon, well, if it's 25% less, that's 75% of. So that would be 0.75 times 756, which equals $5.67. And so in effect, I want 2 times 12.60 minus $5.67, because that would be the difference, 2 gallons to the one at 2 gallons from Grazier versus the 2-gallon at No Costco. And that's going to come out to be $13.86. So you save yourselves $13.86. For question 21, the table shows the average number of questions answered correctly by 50 students in a 20-question quiz. If the weighted average of the low end would be the bottom of each interval, 0, 4, 8, 12, 16, is compared to the weighted average of the high end, which would be at 4, 8, 12, 16, 20. Which of the following is closest to the range of those weighted averages? Well, there's an easy way to do this. If I look at this, each interval has a range of 4. So the range of each interval are 4. And if I do look at a weighted average of the top end minus a weighted average of the bottom end, well, I'd be taking 4 times 4 plus 12 times 8 plus 14 times 12 plus 11 times 16 plus 9 times 20 and dividing that by 50. And then I'd have to take away 4 times 0 plus 12 times 0 and so forth. And in effect, what I'm going to come out with is an average that has a range of 4. So common sense tells me that C should be the answer. But I could complete this, not 0 here. That would be 4. And 14 times 8 plus 11 times 12 plus 9 times 16 and divide that by 50. Well, I'm going to get an average here that's really going to be all that times 4, and then an average here. And if I look at the differences of the two, it's just going to be 4 times 4 minus 0, 12 times 8 minus 4, 14 times 12 minus 8. It's just going to be 4, 4, 4 all the way through. So that cements that C should be the correct answer here. Question 22. In question 22, the 3 circles in the rectangle shown above have the same radii length of 2. And so I know that this radius, well, actually that to that is going to be 4. And that means that to that is going to be 4. And that means that to that is going to be 4. And all are tangent to 2 sides of the rectangle. Well, I do know that this would be 2, and this would be 2. And so this side of the rectangle should be 8. And I know that would be 2, and that would be 2. Oh, but that height in between, this height right here, because I got to find the area of the rectangle, but not in the circles. So I need that height there. Well, I got an equilateral triangle that's 4, 4, 4 on each side. So this should be 2 rad 3, because that would be perpendicular. This would be 2, and that's a 30, 60, 90 triangle right there because of the equilateral angle. So now I know that this would be 2 plus 2, 4 plus 2 rad 3, because this is 2 and this is 2. So that height of the rectangle. And what I have to find then is all of this area, the stuff that's inside the circle, or probably the square, but not in the circle. So I have to take the area of the rectangle, not a square, rectangle, and take out the area of the 3 circles. That sounds pretty straight out. So I should have something like this, that if I take the area of the rectangle and I take out the 3 circles, that's going to give me the area that's in the rectangle, but not in the circles. So I take 8 times 4 plus 2 rad 3, which is the area of the rectangle, and I take out 3 times 4 pi, which is the area of the 3 circles. And I get something like 32 plus 16 rad 3 minus 12 pi. And I put that in a calculator, and I get 20, that's not a 2, Brown, 22.014, and a bunch of other numbers because of the pi thing and the rad 3 thing. And so I was asked to the nearest integer, so 22 square centimeters. Module 2, question 1. Pepe grows plump pawpaws in a patch on his property in Pittsburgh, Pennsylvania. The past year, Pepe plucked 260 perfect pawpaws from his patch. Present year, his pawpaw patch produced plenty of plump pawpaws, passing the past year by an impressive percentage of 40. How many pawpaws did Pepe pick this present year? Well, you got to figure, despite the tongue-twisting presentation, is that he passed his past year by 40%, which means that's 140% of the past year, this present year. Well, if then I take 1.4 times what we knew he did in the past year, 260 pawpaws, Then Pepe produced 364 plump, perfect pawpaws at his patch on his property in Pittsburgh, PA. And so the answer would be D, of course. I should have circled it to begin with, but I just wanted to get a few popped peas in there to finish up. Question 2. We have a graph, a portion of a graph of some function, y equals a times b to the x, which is exponential. And that has that profile of a sweeping kind of ski ramp thing of going up, is shown above. What is the value of y plus a plus b plus x? Well, I do know one thing, that when x equals 0, this thing would equal 1/2. So y equals 1/2. And I can see if we look at a times b to the 0 is equal to 1/2. And I know that b to the 0 is 1, then a must equal 1/2. So a equals 1/2. And I do know then that, well, when x equals 1, because now we've got y equals 1/2 b to the x, that when x equals 1, this equals 1. And the only way we can have that is that when x equals 1, that would be b to the 1, which would be b, which would mean now that b must equal 2. Because 1 would equal 1/2 b to the 1. Multiply both sides by 1/2, and you got b to the 1 is 2, or is 1, pardon me. Pardon me, b is 2. That's what I meant to spit out. And here, well, at the y-intercept of the function, we already stated that, well, it's going to be b to the 0. That's what we were looking at initially. And so x would have to be 0. And if I add 1/2 and 1/2 and 2 and 0, but pardon me, plus 0, that's going to equal 3. So the answer is 3. Question 3. Brian is exactly 2 meters tall, yet his driver's license has his height printed in feet and inches, and it's rounded to the nearest inch. I could pull it out and show it to you right now, but then you get all my information, and, well, enough about me. What is the height printed on his driver's license? Noting that 1 inch is 2.54 centimeters. Well, if I look at 2 meters, that's 200 centimeters. And I divide that by how many centimeters are in an inch. That should give me how many inches tall. And if I know that there's 12 inches in a foot, well, 6 times 12 is 72. So this would be 6 feet, and it would be 6.74 inches added on to get the 78.74 inches. Because remember that this was centimeters and this was centimeters per inch. And we then round up. So on his license, it says 6 feet, 7 inches. So C is the correct answer. Question 4. Birdie is a leopard tortoise, currently holds the world's land speed record for any tortoise species. This is true. This birdie's a real tortoise. Tearing up the test track at a blistering 0.28 meters per second. Now, Usain Bolt, who's a human, currently, well, he did when the problem was written, currently holds the same record for his species at 12.21 meters per second. by what percent would Bernie have to increase his speed to match that of Usain Bolt, rounded to the nearest whole percent? Well, this is a percent change problem in effect, so I can take the new value, which would be to Bernie what he wants to go to, Usain's speed of 12.21 meters per second. I can take away Bernie's, which is 0.28, I should say, divide that by Bernie, because we're referencing the growth from Bernie, and multiply that by 100, and that will give me a percent, because I'm using the idea of the percent change formula being new minus old over old times 100%. If it's positive, we went up. If it's negative, we went down. And if I look at this becomes 4,260.7 when I put it into a calculator, and it would be percent. And if I round that up, then Bernie, which starts with B, has got to step it up a little bit to get up there with Usain Bolt. And then he do the DAP point at the end when he's done, which would be kind of cool for a turtle. Oh, pardon me, tortoise. Tortoise is different. Question 5. Which of the following expressions is equivalent to 24s minus the quantity 5s minus 2s? Well, I could look at this in a couple of different ways. I could apply the minus sign and then add 3 terms together, or I could look at the fact that this is just going to be 3s. And so it's going to be 24 s's minus 3 s's, which should give me 21 s's. So 21s leads directly to A as the correct answer. Question 6. What is the largest value of the range of this given function? Take 2. Question 6. What is the least value of the range of the function given? Y equals 2x squared plus 6x minus 17. You could graph this thing in Desmos right away. That would be an easy thing to do. Or you could realize that it does open up because the leading coefficient is 2, which is positive. So it would have a minimum, which would be on the vertex. And so it would be when x equals negative b over 2a when it's in standard form of ax squared plus bx plus c equals 0, which it will when we're looking for solution. But we can recognize that, and so this should be a negative 6 over 4. Or better yet, easier to work with, negative 3 halves. And so I'm going to stick that back into the function to find out the minimum. But I've already looked at the graph and seen that it's going to be at negative 21.5. It's going to be B, but I can show that here because 2 times negative 3 halves squared would be 9 halves, 9/4 times 2. And I'm going to take away 9. And then I'm going to take away the 17. And I'm going to end up with negative 43 over 2, which is negative 21.5. So B is your answer. For number 7, for the equation y equals the cube root of x cubed over 125, well, note something, that 125 is 5 cubed. And if I take the cube root of x cubed over 5 cubed, then really what I've got is y equals 5 times x over 5. Or better yet, the line y equals x. And I can put any real value in there. So all real values would solve that. So D is your correct answer. Remember, in a cube root, I can have negative x's, I can have positive x's, I can have 0. And so I can stick anything into that thing. But the fact that we were able to simplify it into what it would graph as would be the line that goes to the origin at a 45-degree angle. Of course, we can stick anything into that. For question 8, in question 8, I know that y equals this and y equals that. Well, then this must equal that. So x cubed plus 8 must equal 72, which tells me x cubed must equal 64. And I would put that in a calculator, but I do know for a fact that 4 cubed is 64. So x would have to be 4, and A is the correct answer. For number 9, I'm given a circle. I'm told that this is a 90-degree angle here, and I'm asked to find the value of QPO and QRO, which would be these two right here. Now, I know something right away. I can draw a radius here, or I can note that the inscribed angle must be 45. That would help, because that's just going to show that if I did draw this radius from O to Q, it would bisect that angle. And all the radii are the same length. So this triangle QPO and this triangle QRO, pardon me, I didn't mean that there, are isosceles, which means that this angle here is congruent to that angle there, and this angle here is congruent to this angle here, and both of those make up a 45-degree angle. And so the sum of these two, which must both be 22.5, it would have to be 45 degrees. So your answer is 45. For question number 10, the polynomial y equals the sum of 3 lines has a y-intercept of 6k. If 6k represents a non-irrational constant, which means it's got to be rational, what's the value of k? Well, there's something I want to point out. I did in an earlier problem. You may not have gotten that one wrong, but if we did multiply this out, it's going to be a cubic function. It'll have an x cubed on one end when I multiply x times x times x. But then on the other end, well, it's going to be the product of -3, -4, and -5. So I should have a -60 on the other end, and then a bunch of other stuff in between. I don't have to multiply it out, but I could. I could graph it and see the y-intercept, which would be at -60. But now I know that 6k has to equal -60. Well, k then would have to be -10. And B is your answer. Question 11. The scatter plot below shows a relationship between the age of a mother at the birth of her first child, B, and the number of years of education, E, the mother recorded at the time of the birth. A line of best fit has been added as a potential model for the data. Now, that being said, which of the following equations best corresponds to the line of best fit? Well, let me scroll out a little bit here. Or scroll down a little bit, I say. And get rid of that. Damn it. That's not going to work. We're going to retake it one more time. I'll just draw the line in and then scroll down. Um, we might have to retake this one because the diagram doesn't have the line. On the copy I have, the print copy I have, it has the line. Let's do it from right here. So hopefully last take at number 11. Question 11. We're given that the scatter plot shows a relationship between the age of the mother at birth, which is the x-axis, versus the number of years of education the mother had at the time of this first birth. That'd be the y-axis. And there would be a line of best fit then that you could plot, which is shown here. And we want to know what would be the best equational model of the four choices that would give education as a function of age at birth of the first child. Now, something you want to note right away, whenever they give you a graph on the SAT, odds are, I shouldn't say pretty good, but it's done here that the origin represented is not the true origin. We need to extend the graph, and if we do that, we need to extend the line. And so if we were to put the actual y-axis in, it should be over to the left by a good, oh golly, maybe right about here. And if we were to put the x-axis in, well, that might be on this scale way down here. And that would mean that this line would intersect well below 12. Now we can calculate the slope here. We can see the slope by just picking a couple of points. Oh golly, um, maybe one there, which looks like about 2015, and then one here, which looks about, 30-20-ish maybe. And we can see that the slope then is going to be approximately 1/2, just by eyeballing it. In fact, it's a little less than that. It's about 0.4 something. Oh, okay. So it's going to be the one with the slope of 0.4 something. A little bit less than 1/2. So A would be your answer. And that justifies that the y-intercept then would be down here. Where if we 10, then 8, then 6-ish would be the y-intercept. So watch out. They love to do this with their graphs. And A is the correct answer. Number 12. On number 12, we have a system of equations. And we're told that it does have a single solution. And so if I stick A and B in there, I would have something like 2A plus 3B equals 21, and 5A minus 4B equals -5. Well, I can solve for A or B in either of those. In fact, I can take this idea. I'm going to take 4 times the first equation, which will give me 8A plus 12B equals 84. And then I'll take 3 times second equation, and that'll give me 15A minus 12B equals -15, and then just add those guys together. And I'm going to get 23A equals 69, which tells me that A must be 3, and I can, stick that into either equation to find out that B would equal 5. So the ratio of B to A should be 5 to 3, which thankfully is an answer. And even better, it's the correct answer. Question 13. A certain right rectangular prism, which is a box, has 3 quadruplets of equal length edges. Well, you would think that in a box. I mean, I'm going to have the width of the box, the length of the box, and the height of the box. And the height's going to have 3 other heights, and the length will have 3 other lengths, and the width will have twins, quadruplets. And they said that this thing was 3 by 4 by 5. And what is the volume of the prism in cubic inches? Well, 3 by 4 by 5, 60. Width times length times height, which is given in the reference, would be 60 cubic inches. So C is the correct answer. Number 14. In number 14, we're given an exponential equation up above. The equation above is often called the 3/4 life formula. Well, that makes sense because we're taking 3/4 of something for every time unit. I'll buy it. And it gives the amount of 1,000-gram sample of a very radioactive isotope of vibranium that is left after T years of decay. What percent of the original sample is lost to decay between years 3 and 4? Well, I could do this. If I've got 1,000 times 0.75 to the 4, that would be how much had been lost by the 4th year. And then I take away 1,000 times 0.75 to the 3, which had been all that had been lost up to the end of year 3. Then that would give me what was lost in between. And if I look at that, that's the same as 0.75 to the 4 minus 0.75 to the 3. And I can put that into a calculator and I get negative 0.105-ish, which would be minus 10.5%. So we lost that much. Question 15. In question 15, when the equation above is graphed on the XY coordinate plane, it has 2 solutions. And I want to know what's the distance between the solutions. Well, I remember from class that the distance between any 2 solutions of a quadratic is going to be b squared minus 4ac square rooted over a when it's in standard form of ax squared plus bx plus c equals 0. So I'm going to try and get this thing into that form. So I'm going to, well, what would I do? I got to distribute. So 2x squared minus 2x plus 14 is on the left. And then 5x squared plus 11x minus 15, then minus 1 is on the right. And that's going to clean up to 3x squared plus 13x minus 30 equals 0. And, well, that's got a factor as 3x times something, and x times something equals 0. And however you factor, you can find now that to get the negative 30, I probably had negative 5 times 6 or negative 3 times 10, like that. But you'll come to that, whatever way you factor. And so now you can see the roots of this would be x would be 5/3 or x would be negative 6. And on a number line, the distance between the two would be 5/3 minus negative 6, which comes out to be 23/3. And note what I said originally. Well, we've got it in ax squared plus bx plus c form. And so I could have just looked at the square root of 13 squared, 169, minus 4ac, so it'd be plus 4 times 3 times 30, so plus 3c. And that would all be over 6. And when I clean that up, I would have gotten rad 529 over 3, which would have been 23/3. So either way, 23/3. Now note, I could also enter that as 7.666, 7 followed by Satan's decimal, or I could have entered that as 7.667. And so I would always enter the fraction on this just to be, because it was a rational value. I'd only enter a complete decimal set if it, couldn't be written as a fraction within the space provided. Number 16. In room 222, there are 42 students with a mean height, of 69 inches. In room next door, 223, the 38 students there have an average height of 6 feet 3 inches or 75 inches. If the two rooms are combined, what's the mean height of all? Well, 42, 38, that's 80 students. And the total for room 222 would be 42 times that average, 69. And the total for room 223 would be 38 times that average, 75. So that's the total height over the total number of students. And that's going to be 5748 over 80, which comes out to be 71.85 inches. And we wanted to round it to the nearest inch, so they're all 6 feet tall, or 72 inches. Number 17. The graph line can be described by this, so you could graph it. You're allowed to. If that line then moves down by 3.5 or 10/3 units, what is the sum of the coordinates of the x-intercept of that translated line? Well, like I said, you could graph this thing and move it up. Or algebraically, you can say that, well, the line that we started from would have to be 4/3 x minus 13/3. And then we took that thing and we moved it up by 10/3. So we added 10/3 to y. So this represents a translation of up by 3 1/3. So now we have y equals 4/3 x minus 1. So there's the new line. And the x-intercept would be when y equals 0. Well, that would have to be when 4/3 x equals 1, which means that x would have to be 3/4. And the point would be on the x-axis at 3/4, 0. And the sum of those two would be 3/4. So C is the correct answer. The value of the number n is no less than 9 more than a third of some number p. So n has to be less, greater than or equal to some number p divided by 3, but 9 more. And no more than 6 less. So n has to be less than or equal to 6 less than triple some number q. So triple some number q, but then take away 6. So n's got to be less than that, but greater than or equal to the thing before. And so we have to put those both together around n, and D is the correct answer. So we had to translate the words into symbols and then connect them together. For number 19, one of the solutions to the equation x squared minus 4x equals 8 can be written in this form. And we want to know what's the value of the product of A and B. Well, if I look at that, I'm gonna do this. X squared minus 4x has to equal 8. And if I complete the square on the left, I take half of -4 and square it, but I got to add that to both sides. So now x minus 2 squared, I built it as a perfect square trinomial that could be rewritten as a binomial square, has to equal 12. So x minus 2 would have to equal plus or minus rad 12. And x would have to be 2 plus or minus, well, rad 12 can be, well, it's already in that form of A plus B rad B. So this must be A, and this must be B. I can just take the plus one. There's two of them. And 2 times 12 would be 24. So B is your answer. Question 20. Given the equation of a circle above, so it's a circle. In fact, I could rewrite that thing, factoring 3 out of everything. Like that. So I just factored a 3 out of every coefficient there. Same thing. Given the equation of a circle above, which of the following values is closest in square units to the area of a square that has a side length equal to the radial length of a circle? Well, then the area of the square must be r squared. It's got to be. Because if the side is r long, this would be the area of the square. So we just want to find the area of the square. And if we complete the square on this equation that we were given, i.e. on the x stuff, we're going to take half of 2 and square it and add that. But remember, we got to add it to the other side. And then we're going to take half of 4 and square it and add that. And remember, we're going to add it to the other side. And we get 12. So we've got then that x minus 1 squared, pardon me, x plus 1 squared, plus y plus 2 squared has to equal 12, which is the square of the radius. Oh, that's got to be the area of the square. So 12 is your answer. Question 21. In triangle PQR, angle Q got a measure of 19 degrees. P's got a measure of 53. Let's draw that. So there's P, and there's 53, and I'll say that's Q up there, and this is R. So this is 53, and this is 19. And what is the measure in degrees of the exterior angle by extending QR past? So I got to extend. And so I'm extending this side past that intersection. So they're talking about this angle right here. What's the measure of this angle? Well, they used to ask this on the SAT every test for 50 years, and it was called the external angle theorem, in that this angle here must be equal to the sum of the two remote interior angles, because this angle here is supplementary to the angle inside with 53 and 19, and 53 and 19 and this angle here add to 180, which means that this one and that angle, I'll call it X, add to 180. And so the question mark must add to the two things that we were given, which is going to be 72, because this one side X would have to be 108, because that and that and that got to add to 180, and this got to add to 180, and there's your friend. Question 22. In the system of equations given above, n is a positive integer, and the system has no single solution, which means it's got to be parallel, have no solution, or it could be the same line, which would have infinite solutions. So there'd be no single solution. Cool. So you can graph these things. That's what I recommend. It's the last problem. You get Desmos, graph those things just like they are. And I think you'll see something right away that, well, let's talk about it. I could do this algebraically. I could multiply out the top, and I'm going to get something like 3y plus 8 equals x. When I apply the 3/4 to each of the terms on the left side of the first equation. And I can multiply the whole second equation by 9, and I'm going to get 8x minus 16 will be 6y. Now I can take that and put it into standard form, line them up. So nx minus 3y would have to be 8, and 8x minus 6y would have to be 16. And I do note that I can rewrite the second equation then, dividing everything by 2, as 4x minus 3y would have to equal 8. And I note right away that these two, if I look at these two pairs of numbers, would form the same y-intercept. So these two lines are going to cross at a single point unless I can make n equal to 4, and that would make them the same line. And then they would have no single solution. No single solution. They'd have infinite solutions. So if n was 4, then they're the same line, which means infinite solutions, which means there's no single solution. So n equals 4.